Well, I'll start off by saying I don't normally look like this. I tripped yesterday on the way to Steve's party, and I have two regrets in this order. Regret number one, I missed Steve's party. Regret number two, I'll probably scare the hell out of my grandchildren. But Steve's party is the important one. And I know that I'm speaking largely to people that don't know a lot about minerals and know a lot about mathematics, much more than I do. But I'll start with the way you look at Steve Smale versus the way that I look at Steve Smale. He's a genius in both parts of the world, and in both of them, I think he is regarded as a perfectionist. So my measure of perfection is what I'm trying to talk about now from two perspectives, and I'm going to try and do something which is the equivalent of the particle versus wave problem in physics. It's either a particle or it's a wave until you measure it, and then it turns into whatever it's going to be, a particle or a wave. And with Steve, if you talk about him as mathematics to a mineralogy person, they will think about an entirely different part of the mathematical field than Steve works in. And I'm sure if you talk to a mathematician about his mineral collection, you wonder why does anybody go out and collect rocks? So I'll try and put those two things together. And I'll start with the Solvay conference back in 1927, which brought together many of the very famous physicists and mathematicians of the world. There are a few of them that were there, of course. There's Einstein. Particularly important to me as a crystal collector is Madame Curie, because she did a lot on the radioactive minerals that became so popular once we understood what they were. But it's a combination of people that basically started the whole field of quantum physics and all the things that go on, cosmology and so forth, as we know it today. There's my equivalent picture from the mineral world, which I think Steve probably will remember. It was taken a number of years ago at a person named Bill Larson's party. Bill Larson was one of those founders of the current mineral world. He discovered he and Ed Swoboda, and there's a picture there, discovered a mine in California that became world famous, and nobody really recognized it but Steve. But these are the people that really began the whole thing of the world. There was Charlie Key, Peter Bancroft, who is a very famous collector and scientist in Arizona, Ed Swoboda, who was, interesting sideline, Ed Swoboda, who died a number of years ago, was a very great mineralogist, and he discovered a lot of minerals and he did a lot of things, but he also collected quartz crystals during World War II to make walkie-talkies. And he and a person named Cliff Rondell from Harvard and one other started a company during World War II to make the quartz crystal oscillators, and it was a program not as big as the Manhattan Project, but it was as important because it allowed the troops on the ground to talk to each other through making these oscillators. And Ed was one of those founders of that crystal mine, the Tourmaline Queen mine. Bill Larson, who still is around, he just celebrated his 80th birthday, and he's one of the founders of this Tourmaline Queen mine, which I'll mention more about in a few moments, and Steve. Now, unfortunately, I happen to be getting up into that stratosphere of age, which when Steve turned 85, I said, my God, 85, that's old. And I'm 88 now. And one of the great collectors of minerals, in a sense of artistic beauty, is Jack Halpern, who has just turned his 105th birthday. Steve at 95 now. Bob Jones recently passed away. He was 95, and I was there at just an 88-year-old child. But there's 350 years of mineral collecting there. Now, this is the thing that started the whole system of phenomenal minerals and the price rise that people have seen since. Now, just another word to the side here. I regard the natural crystals of the world, such as these, much as any artist would regard a Mona Lisa or a Picasso or whatever that they look at, or as any musician we regard a Beethoven or a Mozart or whatever. These are natural creations. None of these have been touched by anybody to make them any more beautiful or form them. This is the way they were dug out of the ground in 1972 in one of the most famous mineral collection successes in the world. And I happened to have visited the mine in 1972, about 3 weeks after these came out. And I went to Bill Larson's house. He was the person who was in charge of all this. And he wanted to sell them, and you could buy a specimen like one of these for about $6,000 to $10,000, which of course at that time was an astronomical sum. This one here in the upper left is at the Smithsonian, and it's probably worth $25 million. This one here on the bottom left is the famous one with the morganite. And it's worth, I don't know, you can't really tell what it is because you can't get them. They are unavailable. They're in private collections or in museums. But there's probably $50 to $100 million worth of rock shown in that thing. And that started off as, you could have bought the whole thing for $20,000 back in 1972.
Which one was 20,000?
Pardon?
Which one was 20,000? Which one was 20,000 in 72? All of them?
Probably the candelabra. And don't quote me on the number. I just made it up.
I'm right. I am quoting you. Yeah, the candelabra.
This is one of the famous pieces that Steve had, and it starts to get into the kind of talk that I'm giving about perfection. This is a perfect specimen. It's one of those tourmaline crystals from the tourmaline queen. You can tell by the very, very beautiful blue top, matrix, no damage, no fractures, no nothing. It's just a perfect crystal. Now, you have many, many papers by famous mathematicians in the past that, become a treatise for all kinds of things, for math or whatever, even going back to, I guess, to Archimedes. These are the things that make things famous now. And it turns out these little pieces of paper, which are labels for mineral specimens, add to the value of a mineral. So, it could add 10% to the value of mineral because it belonged to Steve Smale. Now, beauty. Here's where I get into trouble because I have no idea what I'm talking about. Perfect numbers and perfect equations. Perfect equations, as far as I understand, are equations that require no simplification, no normalization. They just stand as they are, and they relate objects to other objects without any assumptions whatsoever. E equals MC squared. All this formula is invented 4 numbers, put them together, that equals 0. And they stand by themselves. They are perfect. And similarly, the perfect numbers, 6, 28, 496, which are where the sum and the product of the sum of the digits and the product of the numbers are the same. And I guess, I don't know how many of them there are now, 50 or something like that. Fortunately, perfect specimens are more plentiful and easier to obtain than perfect numbers. I think you have to go something like 3 million years to get the next perfect number on a supercomputer. But here you can actually get perfect crystals by digging. These are beautiful specimens, and the rest of the specimens are or have been in the Smale collection at one time or another. The right one is a tourmaline crystal, the left one is an azurite malachite. To me, these are the 2 types of minerals. These are matrix specimens where you have something on another material. These are single crystals, which always are of interest to me because I studied the properties of single crystals when I was a student and working at Intel. All these cell phones you have are due to the silicon technology that I worked on 60 years ago. Terrifying. It's another one of the specimens. This is a specimen collected by a gentleman named Wayne Thompson, who is sort of a modern hippie, I would have to say. He just turned 70, but he was pretty young when he found these things. He found them in a mine in northern Mexico, and he became very famous as one of the great collectors, and Steve acquired this specimen. Now, the other part of it is equations. Let's go back and talk about some of that. F equals ma. Well, what's the mass? Take the mass of the Earth, you got to go through all kinds of complicated things to figure out the radius of the Earth, the density of the stone, the homogeneity of the Earth, whatever. So you spend a lot of time dealing with that. Steve spends the equal amount of time well, first of all, I'll say Steve obviously has a number of equations named after him. This is the 7th. I like Beethoven's 7th Symphony, so I picked this one out. I have no idea how many equations are Steve Smale equations. So I named my equation Steve's nth equation. Now, this is all correct. Steve doesn't know anything about it, and he probably doesn't agree with it, but the summation of V, of value, if he wants to trade a specimen from person A to person B, and person A has a whole bunch of stuff, and Steve has one of his perfect specimens, person B says, person A says, I want to trade, Steve thinks of a way to make a trade worthwhile. So the summation of the value of all the specimens that the person has to be greater or less than, that value with n in dollars, which you may have to use to balance it off, that's normalization, has to be greater than the value Steve puts on his specimen. Now, what does the value of Steve's specimen? That's the value of a locality where it's from, which adds to the importance of a specimen. The perfection, which is something that I'm going to give a few more minutes about, called a Wilbur. So it's another term that was invented to make the equations fit. Perfection, color, size, millimeters to very large specimens. Rarity, just a comment here, I think Steve would agree that he doesn't care about rarity. There are a number of very, very valuable specimens that occur, little tiny black specks on some rock. That is not of Steve's interest. Steve is interested mainly in beauty, and therefore that's why it gets the exponent that is higher than the others, because the beauty he respects is greater. And the price, did he buy it, how much did it cost? And n is some integer which says how many dollars you're going to have to give Steve in addition to specimens in order to get a Steve Smale specimen. So he may like this nth specimen, nth equation, but I have no idea. He may be just saying, Gene, shut up. Now this is a Wilbur. Dave Wilbur was one of those founders of the early days of fine crystals, and he collected fine crystals just about the same time as Steve. And the Wilbur was named after some people who were looking at specimens, and you find a little tiny damage. Now that little this is not a particularly valuable crystal, it's a pyrite crystal, $100, $200, whatever. That little nick will decrease the value by perhaps 50%, or to somebody like Steve, it decreases to 0. He has no interest in a specimen that has a Wilbur, even though he and Dave were great friends. Here's another pyrite. This is what attracts me once. That's a cube that you dig out of the ground. You just go into places, this ones are from Spain, you go into a wall of clay and you start chipping away and you see the edges of these perfect cubes. That's what started me collecting minerals when I was 7 or 8 years old, and you just cannot believe it. That's what you dig out of the ground. It is not touched, faceted, cut, polished, or anything. This is exactly as it was found. This one happens to have a Wilbur on the back, and again, Steve would not have it. This is wolfenite. This was collected by the guy I told you before, Wayne Thompson at the Red Cloud Mine. That little part on the edge is a Wilbur. Steve will occasionally accept a Wilbur if the specimen is other extraordinary value. Now, to give you a better idea, this is my specimen of tourmaline from Afghanistan. I consider it a really nice specimen, very pleased with it. There's Steve's specimen. Okay, which one would you choose? I'll ask Steve, would you trade yours for mine? Possibly in a million years. Now, Steve has one other property with the equation. He deals in quanta. He's quantized this. I don't know if you've even thought of it, but yes, you quantize this. And here's the example, going to the Smale, this tourmaline queen tourmaline again. It was owned by somebody, and Steve owned this one. Somebody wanted to trade for it. I think it was Wayne Thompson that wanted to trade for it. To Steve, this is worth 25 quanta units, where a quanta unit might be, $200,000 or $1 million or whatever it is. But Wayne had to come up with a number of specimens where his price and quality and locality and beauty and perfection had to sum up to some number greater than Steve's things in quanta. So Steve would say, yeah, this is 25 units. And Wayne said, well, this one's 3 units, and that's 4 units, and this is 7, and that's 9, that's 21. Will you take it? And Steve laughs at him. So Wayne would add another one. This is 1.5 units and 2.5 units, and it'd be 24.5. And he would say, will you trade for it? And Steve would say, no, because you just don't find this kind of a specimen very often. And Steve had a considerable number of them. Let's go through some of the specimens to get an idea. Some fluorite, barium sulfate barite, garnets. All these minerals, again, I just want to stress, are the way that you find them in the ground, and they represent a whole variety of different crystal structures. But back in the 16th, 17th century, people started using microscope to look at these crystals, and they determined through refractive index, reflectivity, and the crystal angles that there had to be only 7 ways that these crystals could be formed. So there are 7 crystal structures. Out of these 7 crystal structures, I'll give you an example, a perfect cube, an atom on each corner of a cube is a perfect cube. If you stick an atom in the corner, in the center of each face, you get added more atoms, but it's still a perfect cube, and that's a face-centered cube. And if you take one of those atoms and put it in the center of the cube, you get body-centered cube. So you have 3 forms of cubic minerals, and when you add all those together, you get 14. And these guys discovered that. It's back in, 1800s, 1900s. Then one of the people that was in the picture of the Solvay conference, Bragg, started doing X-ray diffraction on these things and found out that, yes, indeed, these people were correct. And I consider that one of those miracles of mathematical processing and a genius and an observation that they were, through X-ray diffraction and completely different technology, verify and not create even more crystal structures than the 7 crystal structures, 7 lattice types and 14 crystal structures that came out of them. But every one of these crystals, regardless of their external shape, belongs to one of those 14 lattice groups. It's a garnet. There are 3 of the people that really put things together. Steve does not collect. I mean, he's not known for going out and collecting minerals out in the field. Gentleman on the right is Barry Ample. He is known for, at one point, having the best mineral collection in the world. He became very wealthy, developing software for, it wasn't Bell Labs, but it was very related to Bell Labs. And Bill Larson, who was the one who discovered this tourmaline queen, which turned the faucet on. As soon as the faucet was turned on, Barry respected that and started buying a lot of really fine specimens. And Steve, who recognized the value of the perfection of the specimens, would buy specimens. So these 3 are sort of the people that turn things on. And I call Barry, I call him Euler, because Barry was an unknown. So Euler's formula until recently was unknown if there was an ad. No, it's for Matt's. I should have the names reversed. Pretend the names are reversed. So Fermat and Euler, these are the people that started the industry as we know it today, which is, there's a show in Tucson called the Tucson Gem and Mineral Show. And during this 2 weeks, 3 weeks, 4 weeks we're there's probably $500 million of rocks exchanged, rocks and gemstones exchanged. Grown from a big thing. Tucson started largely because of this tourmaline queen find. Beautiful barite, heliodor, which is the yellow form of, if this stone were green, if it was chromium, it would be called emerald. If it was blue, it would be called aquamarine. If it was yellow, it's called heliodor. If it was red, it'd be called morganite. If it was colorless, it'd be goshenite. But it all depends on minute amounts of elements that are distributed through the crystal lattice that give it its color. Tourmaline, which is a very common mineral, but finding them in this quality, with this shape, with this perfection is very difficult. I could go out tomorrow morning and buy a tourmaline crystal that looks like that for $25. No problem. Just one telephone call and it would come in. This is worth a lot more than $25. Just a beautiful work of nature. Fluorite, that's an aquamarine, the green variety of beryl. Wayne Thompson, who I mentioned, was one of the persons that actually dug these things out of the ground, dug most of these wolfenite crystals that you see from Arizona. A very unassuming person, but you just can't believe that this person, Wayne Thompson, knew as much about all the mineral specimens in the world that were great, and therefore he knew all the dealers like Barry Ample or Steve or whoever, was able to just build up his reputation as a great mineral dealer at a very young age. Topaz, this comes from a very famous mine in Brazil, and that mine turned out tons, not tons, but a lot of these topaz crystals, many actually better than this. They were transparent, belonged to that first gentleman I showed you, Barry Ample. He owned the mine, and it was the crystals that he pulled out of there were just staggering. Chrysoberyl, calcite, very common mineral, very easy to break, very fragile. Steve had some of the best specimens in the world. These are found in Tasmania, in the deep mine, and to bring them out without breaking this thing is a phenomena. So, have to hand it to the people that dig as well as those that collect. You all right? So there's a collector's lineup. I happen to be in the lineup because I did have a fairly nice collection. There's Wayne Thompson, Bill Larson and his wife Jean. There's Steve, Barry Ample, and Clara. It's just a nice picture of the collectors. Now, Steve works in mathematics, and he's been working most recently in natural language processing and all that. So we asked AI chat box, what do you think of Steve Smale? And as you might expect, you come up with something which is very, very impersonal. Steve graduated from here, he went to Michigan, he did this, he had the Fields Medal, he went here, and he did that, and he became very famous, and blah, 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 blah. Not very satisfying, although some of the words in red are quite nice, and if anyone wants copies of these, I'll give it to them. So I said to the AI chat box, I said, no, what do you, AI chat box, think of Steve Smale? And it came up with a different answer. So now it starts to get into Steve is a charming, what kind of a person, and he's easy to get along, and blah, 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 and all that sort of thing. And that was better. And then I decided to ask it, what if you were Euclid? What would you say about Steve Smale? And so there's another description of Steve Smale as Euclid might have seen him if Euclid were inside one of these chat box things. But Euclid lived a long time ago. What does he know about cell phones and all this stuff? So I asked another one, I said, what if you were Ramanujan? What would you think of Steve Smale? And you get an entirely different one. And it's really fun to see how Steve would look to a machine that thinks that it's one of these people. We get a kick out of that because they come out with different views, with different values, different perspectives of what Steve is. So you think of Steve. Steve has other passions. He does do other things besides mathematics and collecting rocks. This is at a party at Tucson many, many years ago, about 8 years ago, 8 years ago. What do I think of Steve? When I first met him, I knew he collected really nice rocks. The first time I saw him, he was walking through the Tucson Gem and Mineral Show, big piece of torbanite, a green mineral from Africa, and I had never seen anything like it. Then I started seeing him at the shows at a person named, I forgot his name.
Charlie Key.
No, from Tumeb.
Gephardt?
No, you know.
Peters?
Huh?
Peters? Forget it.
No, not that. He used to come to Tucson with, and Jack would be there and all these people.
Forget it, who cares?
We'll find it later. But he would come and put out those things, and another person that lived in the Bay Area, a guy named Mel McGinnis, would put out his, and other dealers would put out theirs. And you could tell what was going on because Jack Halpern, who I showed you a picture of, he turned 105, always picked out the ones that were the most beautiful because he was an artist type. It had to be beautiful in this case. Might not be worth anything, but it was beautiful. So his value on beauty was high, and his value on scarcity, rarity, price value was very, very low. But people knew that he had great taste in picking out artistic things. So you see Jack walking along, and behind him there'd be a troop of people waiting until Jack picked up something, looked at it, and put it down. And then he would swarm to get it because they knew Jack was interested. And the same thing with Steve. Remember watching him go through some of these, and then people say, well, if Steve picks it up, it's got to be something really good. So anyway, Steve is acknowledged brilliant. I once tried to engage in him what I thought of a mathematical thing about crystal lattices, which to Steve are pretty like, arithmetic or something. I have always found him courteous. I've never seen him. In mineral world, there's a lot of killer people, sharks that, they say of one of these dealers, you put your hand out of a rowboat and you'll pull back a bone. Steve has always been courteous to everybody, kids, wives, husbands, dealers, collectors, whoever. He just has this property. Conversational. He never turns anybody off. He doesn't say, I'm too tired, you're too stupid. He's just conversational. He engages in them. He is a perfectionist, I guess, in both professions. He is gracious, such as putting on the parties like last night, which I unfortunately missed. He is generous. These kinds of parties, for example, are an expense and a cost. And Steve has always been generous with both his finances as well as his time. And the thing that gets me most is that I deal with a lot of these people. I've also dealt with a lot of great physicists in my time. And I dealt with all the people that started the semiconductor industry. I knew all of them. Some of them were pretty gracious, some of them were pretty rude, some of them were pretty obnoxious. But there was none like Steve. It's just something about the way he is that really captivates you. So if you ask me what I think of Steve Smale, that's what I think of Steve Smale. Some of his specimens and Steve Smale.